Alright, so let's take a look at outliers. So, when we have a set of data, one thing that can happen is we can have a number that's very unusual, and that would be considered our outlier. And so there's a couple ways of doing this. There's an actual calculation. Our number one thing is that, let's do this. Let's come back here and let's take a look at what the tutor says, okay? So if we go to tutor, and we go step by step, you can see here that the first thing they're going to ask you for is that to utilize this formula. And our formula is 1.5 times the interquartile range above Q3 or 1.5 times the interquartile range of Q1. So the first thing is we have to do is find the Q3 and the Q1 so we can subtract them and find the interquartile range. So here's our set of data. So once again, we pull up our graphing calculator. And if we want to find the interquartile range, the easiest way is to plug these numbers in. So we go to Stat, we go to Edit, we clear our list, and now we type in our numbers. 42, 45, 37, 28, 24, 21, 25, 48, 26, 55, 30, and 1. So as you're typing those in, or as I was typing them in, did you see any numbers that seemed like they might be different than the others? Like maybe 1? Or maybe 55? Extremely small, extremely large in relationship to the others. So remember, a couple things we can do here is that we want to calculate the 5-number summary, which is one variable stats. Before we do that, make sure you count your numbers out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And you can see here that that's number 14, and then 15 is empty. So we're ready to go. So we hit stat. We go over to calc. We choose one var stats. And once we're on the one var stats, we got our numbers in L1. Frequency stays the same. We go down to calculate, and remember that's our magical screen. So this is the guy we want. Whoops. Let's go down to where we want to get our 5-number summary. All right. Pull this guy out. Put him away for right now. So remember what we have here is that let's look at our big picture. So our big picture is like our box and whisker plot. You're not required to draw the box and whisker, but we can kind of talk about some stuff and see what's going on here, and then we'll do a quick calculation. So if we had a number line, we have our minimum value is 1. So we'll just kind of start this thing like this, and our maximum value is 55. So that's 1. Our max is 55. Our median is 29. So let's see, if we went by 5s, let's see, that's going to be pretty hard. Let's go by 10s. So that would be 10, 20, 30, 40, 50. That's pretty close. So 10, 20, 30, 40, 50. And that's kind of just this very quick, rough breakdown of this. So now we place our numbers. So we know that we have a minimum here, we have a maximum there, we have a median right there, we have a Q1 at about 24 right there, and we have a Q3 at 42 right there. So that means we put that box and whisker on this guy, we're looking at something like that, my box plot. So looking pretty good, but if you'll notice here, you can kind of see here how this guy is kind of stretched out. So he might have a little bit of skewed to the right maybe. This guy down here is a little bit stretched out, so he might be an outlier, but we have a formula for that. Our formula is 1.5 times the Q1, and that would give us like a lower cutoff. So I'm just going to go ahead and install that, a lower cutoff value. Or we can do 1.5 times Q3, and that would give us an upper cutoff. And you'll see in just a minute when we calculate it, like a number value saying if you're anything outside of this, then you are an outlier. So we take this guy, we have our Q1 and our Q3, and oh, I made a mistake. I'm sorry. It's 1.5 times our interquartile range and 1.5 times our interquartile range. And so and that value, let's take a look at that real quickly. You can see So it's 1.5 times greater than interquartile range above Q3. Alright, so I'll help you translate that in to make sense of that, alright? So interquartile range, so our IQR, oops, pen's messing up on me again. Let's go up here. My IQR is Q3 minus Q1. So that's going to be 42 minus 24. Pull out my calculator. Oops, wrong button. Pull out my calculator, and I've got 42 minus 24. So my interquartile range is equal to 18. Okay, so now to find that lower cutoff, so this would be my lower, I would take 1.5 times my interquartile range, which is 18, and then that will give me a data value. So pull that calculator, 1.5 times 18 gives me 27. Okay, so now remember what's going on here with this number is that we look back at this. This is saying that it gives me as this outer limit 1.5 times the interquartile range above Q3. So we come back here and we say, okay, well, our Q3 plus our 1.5 times the IQR. So our Q3 is 42 plus our 1.5 times our IQR is 27. So our upper cutoff would be 969. So we look at our data set. We do not have any numbers that are greater than 69, so there are no outliers on the upper end. So now we go look on the lower end. So on the lower end, we do Q1 minus 1.5 times the interquartile range. So Q1 is 24 minus my 27, and that's equal to negative 3. And so obviously we don't have a negative 3, so there's no outliers there also. And so in this case here, our solution would be no outliers. So let's just say hypothetically that we did one of these and we came across, like one of these calculations came across and was like 5. And so our cutoff number, our 69 or our negative 3 was 5. Then that means in this particular case that 1 would be an outlier if this was that kind of example. All right, so finding the outliers of a data set.